Good evening, guys. Welcome back to a new video. So I have made something pretty cool. At least to me, it's cool. So I thought I will make a short devlog or more like a showcase video. So before I delve into details of what I have made, let me show you an example. So it's an agent. I named it Immortal Agent. I gave it this task where I basically asked it to search for the three most recently released core libraries, and for every library I asked it to find the GitHub page and write a 5-line summary and put it into a temp folder. Then after that I asked it to mail me everything, and also asked it to set a recurring task for every Monday at 9 a.m. that will run the research pipeline and will email me again, right? So pretty generic stuff. And it ran all these tools: bash tool, web search, spawn agents. Oh yeah, it can spawn sub agents. It's pretty cool. And I believe these all bash tools were from the sub agents only. Then a web search, then bash tool, and at last it showed its final response. So it saved everything to the research folder, the final report as well, and it mailed me the entire report as well. So that's pretty cool. So you must be wondering what's so special about an agent that does all this, because OpenClaw does this, um Hermes agent does this. But see, the coolest thing is that how I basically designed it, how I like what was my mindset before I started working on this project. And before I go into more detail, I want to show you another agent that I built. So, oh, I don't need to do this. I can just do, yeah. So this is my Ask agent, Ask CLI or something you can call it. It's entirely based on Gemini. The entire backend is made only for Gemini models, because at that time I only had access to Gemini models because no other lab provide any kind of free tiers. OpenRouter does, but some models do not support tool calling. Some model does, and since it's free, um, the throughput is really low. Like sometimes I have to wait for like 1 minute or maybe 1.5 minutes just to get a single response. So it was not reliable. So I just used Gemini because they are quite generous with the free tier, and I have a Google sub, so they give me $10 per month. So I was able to do the entire thing, the testing, and all that thing under $10. So let me clear the local chat history. Right. So let's say I send it a prompt, hey, it will respond back, right? So after this interaction, I sent it a message. It uh, reasoned about it, and then it gave a final response. After this message, it cannot do anything on its own. It cannot take any initiatives, and I cannot really set a schedule. And even if I can set a schedule, it will not be able to prompt itself. Like it would not be able to wake itself up after it has generated this final response, right? So what I'm trying to say here is, when a model, or any model basically, or any agent generates your final response, the life cycle basically dies. After that, it's not possible to wake them up, or continue without having to prompt them, because the entire architecture of any LLM, or any model that we use, is based on request response cycle. You send a request, they give you a response. After that, to you have to give a new request for in order for them to generate a new response. It cannot go like request response response. This can never happen. So to trigger any response from any LLM model, you need to send a request. That's how the entire systems are designed. That's how current systems, the current LLM system scenario, like pretty much every model are designed like this only. Request response architecture, right? So this means, in order to get a response, or in order to enable the agent to take any initiative, you need to send a request. You cannot, that there is no way to bypass that, right? Because that's how our systems are designed. But for now, like all of the agents I have used, I have used OpenClaw. It's better in this regards, but all of the other agents like maybe Codex, Cloud Code, Gemini. I mean, these are made for coding, but we do call them agents, right? After they generate their final response, they are not able to actually take an initiative. And for me, that didn't make much sense because these models are intelligent. There's no doubt about that, right? Because they are better than most of the humans. They possess knowledge in pretty much every domain. That's not really possible for any human to do. Because so basically, what I'm saying is they are intelligent. There's no doubt about the intelligence, but they are stuck in this architecture that we have made around them, that for them to generate any kind of response, they will need a request first, right? So the same limitation exists in my this application, the Ask CLI. So I wanted to tackle that, and the entire motivation behind making this application was not to just find or more like develop a way to actually make the agent alive. The main motivation was to make an agent that's not catered towards coding, because pretty much all of the coding agents, Cloud Code, Codex, Gemini, all of them are advertised as coding agents, and I believe if we are seeing a future where we will be depending or more like taking help of AI, then we need to make sure that people outside coding, people outside software programming, also get a fair share in the agentic stuff, because agents are not only meant for programming; they are good at various different tasks. So right now there are many coding agents. So I didn't want to make just another coding agent because Codex is good, Open Code is good, coding agent is good, even command code is really good. There are so many good options. You can choose any of them. I wanted to make an agent, basically agentic software, or an agent that is more like a general purpose agent, right? It is not targeting any specific audience. You can just use it for day to day normal tasks, and any normal human, any non technical person can just come here and talk with it. Just like how ChatGPT is for most of the people. Most of the people don't use it for coding, they use it for general questioning, right? Like it's have become more of like a Google alternative, solving assignments, solving questions. Like most of the people use ChatGPT for this purpose. So I wanted to make an agent that is what ChatGPT is to the masses, right? That's how this entire thing uh, was born, because I was just first of all I was participating in a hackathon. I needed a very cool project, and second, the motivation. So I had this thought for a very long time, and also agentic stuff really. Uh, I have like a lot of interest in agentic stuff because the looping stuff, how they keep looping and keep running tools. It really interests me. I wanted to make an agent of my own. So this entire thing was made. So if I show the GitHub page for this project, so yeah, you can come here and give it a read if you want to. But basically, it's a local first agentic CLI assistant with tool use, long term memory, Telegram integration, and text to speech plus speech to text support. Yes, it has tools, and that are like really good tools. I will go into detail uh, after I complete explaining all these things. So it has long-term memory. Yeah, here I will explain later. Then Telegram integration, you can easily talk it over Telegram, and it can take actions on a system and then send response over Telegram. Pretty basic stuff. And then it has text to speech, so it can take your text and convert it to speech and send it over Telegram. I didn't implement it on the local agent because I didn't see any actual productivity gains, right? It's just like a fun feature, text to speech. But speech to text is a really cool feature. So on Telegram, what you can do is you can send voice notes and it will transcribe it and process it like any normal prompt, right? So here's the demo video. I want to talk more about the tools. So yeah, the first one is run shell command, quite obvious. Then comes read file. It reads file obviously. Write file, clipboard. It can read content from a clipboard and put content into clipboard. It has a list. I wanted to implement a to-do type of thing, but for some reason it doesn't seem to use it proactively. Then it has a HTTP request, but for my testing, I have found out that curl is better, so I mostly prefer it to use curl using a run shell command, a run shell tool, because sometimes the format that we need to send a request is quite different, and this tool is not implemented that well, so sometimes the request fails. So I just ask it to use curl via bash. Then the mail tool, it even has inbox, and it was implemented using agent mail. If you don't know what agent mail is, it is, I believe, backed by Y Combinator, yeah. So it's basically an email inbox for your AI agents. It's really cool. It's really easy to set up. You just need, I believe, an API key and your inbox name, and you are good to go. Then it has memories. Memories I'll talk about later. Then text to speech, and send document over Telegram, and send image over Telegram. So now let's talk about memory. So I have basically two databases here. The first one is SQLite, and the second one is Chromium Go, right? This is a, by the way, vector database. I will tell you the entire story. So here I stored local chat history, right? And here I store the memories. So earlier what I was doing was I had another model in loop, another basically API call to the model that will take the user query and filter out the stuff that are actually memories, like stuff that the model thinks are important to remember, facts and different things about, for example, your coding preferences, your favorite food, your favorite color, your date of birth, your height, your weight. So that model will decide what these things are present in the user prompt, and will store them in this vector database, right? And then I will run a query search in the vector database against the user prompt, and it will list, I believe, top 3 to 4 queries, and it will get injected into the system prompt. And it didn't work at all. Like, it did work, but the quality was not good, because the problem was, let's say I have 4 prompts here, right? 1, 2, 3 and 4. Now the problem was, the first prompt was like, okay, like it was related to the stuff I asked, like it was like similar to the prompt. Second was slightly similar, but third and fourth were completely unrelated, which highly degraded the quality of the response that the model generated. And it kept hallucinating because it kept injecting wrong memories. I mean, yes, you could use a re-ranker, but again, if those things are in the prompt, then it's obviously not really uh, gonna help that much, right? So I scraped this entire system. I wanted to make a memory system that's actually reliable. So what I did was, I removed that model from the loop, right? And if I have this agent here, I made it the, like, remove the second model from the loop, and made this main agent the main orchestrator, right? So I gave it CRUD tools: read memory, write memory, update memory, and delete memory. So I exposed this database, the vector database, as CRUD operations to the agent, and gave it tools that allowed it to execute these functions, right? So now the main agent can read the memory, can write the memory, can update the memory, and can delete the memory. So, and it worked out pretty well, because the agent had the entire context of the history of the chat history, and it knew what it needs to remember and what it doesn't need to remember. And later what I did was I removed this read memory tool, and I injected all of this memories directly into a system prompt before any request. The reason why I did that was because sometimes the model didn't decide to use a read memory tool, so it was not aware about the things that it already knows. So I thought, why not remove the read memory tool and directly give all the memories to the agent in the system prompt, because it is the one who decides what memories to keep. So it doesn't really make sense to give it, like, add an extra step for it to access the memory. And this worked. Now every, like, the system prompt contains the memories, and it works well. It knows what who I am. So even if I clear the local chat history, right, it knows who I am, because those things the agent has kept in the memory, they do not get deleted. Only the local chat history, the conversations get deleted. So this thing works. So this was my memory implementation, and it works quite well. So if I clear the memory here, close it and open it again. Hey, what do you remember about me? If I ask this question and wait for it to process, here are the thoughts. So it says you are zephex, a fourth sem BTech student. So I cleared the local chat history, but the memory stayed intact. So this is really cool in my opinion. I hope you do also find this cool. And if you know how to improve the system, then please do make a pull request. I will be more than happy. So yeah. So this is the memory implementation. It has Telegram, pretty basic stuff. It can send voice note, it can receive voice note, it can send images. It also has reply context. So if you, like, tag a message to reply, it will know what message you are replying to. It has shell completions. So yeah, this was the first iteration, but the limitations were, after the final response, it cannot wake itself up. So this was the problem, right? So even if I did give it a tool, like, let's say the scheduling tool or something like that, so that will just run the tool, right? It will just run the code or whatever task I have asked it to, but it will not wake the agent up so that it can take actions based on that. So what I'm trying to say is, if I ask it to check my email inbox every 15 minutes, it will run the underlying code every 15 minutes because I have made a tool for that, but it didn't wake the agent up, right? And there was not really a way to queue tasks. For example, I have 10 questions, and all those 10 questions are like, related to each other. Then there was not a very good way to queue them up so that they execute one after one, right? So I also wanted to tackle that. And lastly, I wanted to make the agent its own entire process, and so keep it so that it stays awake, it doesn't die, so I don't have to prompt again. I'm repeating that thing way too many times, sorry about that. But let's talk about the new implementation. First, let's go to the GitHub, IMMORTAL. An agent runtime that stays alive after a model finishes the response. Like, pretty basic about section. You can read all of this, but this is the main workflow. Okay, before I explain this, I think I should manually explain all this. So yeah. So my main motive was to make an agent that does not die, right? So what I did was, I took this agent and I put it in a separate go routine, which means it will keep running in the background. It doesn't depend and it doesn't die. This part I solved, but I actually want it to perform tasks. So my initial requirements were, it should subscribe to events. It should be able to queue tasks. right? So how can I do that? So my solution, make a channel, because I was learning about concurrency and there's this thing called channels which is pretty cool in Golang obviously. So instead of directly sending questions to the agent, I sent questions or my queries to this channel. Let's name it events channel, right? So I sent all my queries to this event channel, and this agent was subscribed to this channel. Subscribed, yeah. It was subscribed to this channel, so every time any event occurred, it saw those changes and it automatically pulled those what do you call it, prompts, and processed them. So, alright. So what I was saying was, so I took a file. Let's name it request.txt. Right. I took this file and made a go routine that will read this file at an interval of 5 seconds each. gr. So I made a go routine which will basically like poll this file at every 5 seconds, and it will take all the prompts, and each prompt was separated by a new line character. So it split the entire text file at new lines, and this go routine will put all of the prompts in an event channel. So let's make a channel here. So we have this event channel, and since this agent was subscribed to this event channel, my bad, this event agent was subscribed to this agent's channel. This agent was subscribed to this event channel. I saw those changes. So I saw those changes and started implementing executing each prompt sequentially. Now I could add more agents, but the problem I faced later was the chat history, because it's very difficult to synchronize everything, because every agent will be executing a different task, and if your questions have a sequential logic, like they are related to one another, then that will entirely break and it will degrade the quality of your responses. So I made so that there's only one agent that will take one prompt, process it, and then put it back to a file named responses.txt. Responses.txt. Right. So here. So to summarize the entire workflow, I have a text file, right? A go routine will poll that file at every 5 seconds. It will read the entire text. It will split at a new line character, because each each line had a different prompt, so it makes sense to split at a new line character. So that go routine will put all of those prompts in the events channel, and since my agent was subscribed to that event channel, it will see each prompt. It will take one prompt, process it, and put all the response in a response.txt file. I could add more agents, and it is a separate project, because I can make a bulk executor, like something that processes these prompts at a bulk scale, like 100 agents working at the same time. It can be done, but it can only be done in those scenarios where your questions, where your prompts are not related to each other, because otherwise maintaining the chat history, the chat conversation history, it's really difficult. So this is the main core of the entire system I built. Then afterwards I made a Telegram feature. Telegram, and it lives in its own coroutine. So what this means, this polling system will not interrupt the Telegram, and Telegram system will not interrupt the file polling system. So you can literally have two conversations. They are completely separate. The database stores them as in like different channels. The channel for this file polling is default, and for Telegram it is like Telegram, then the ID. So these are two different channels. They will not collide and they will not block execution of each other, right? Because they live in separate coroutines, and every new message on Telegram will call the agent in its own coroutine, so it can process it like entirely in a entirely different coroutine. So they will not block each other, right? And that's basically it. I gave it. Oh, by the way, I also gave it a scheduling task. Now this is the cool part, schedule task. Now how it works is, so it can do repetitive tasks, and it can also do one-off tasks. So, and they live in their own Go routine. Yeah, everything is a Go routine now. So let's say I asked it to check my email every 30 minutes. Every 30 minutes, right? So what it will do is, it will set a Go routine, and basically using tick.ticker, it will run this every 30 minutes, and it will push this message. Oh, by the way, I forgot to tell that Telegram also has its own Telegram events channel. Channel. So it will, and so depending upon the interface you're interacting from, it will at every interval, like every 30 minutes, it will push an event, basically user message, to these channels. And since the agents are subscribed to the channel, they will see those new messages and process the task. So the underlying logic has really simplified. I do not need to write custom logic to actually run the actual thing, because like I have already implemented the email tool. The agent has the email tool, it can do it. So all it does is every 30 minutes it will put a new message saying alarm, check the what's happening here? Check the email. So every 30 minutes it will push a new message to the events channel saying alarm, check the email. And agent has access to the previous chat, obviously, so it knows what this task really means. So it will just see this task and process everything, and this will keep repeating for any number of times the user has asked it to repeat. So like 30 minutes, every 30 minutes it will do it every 30 minutes. So like it had asked it to do like once, it will do it once. So this is how the scheduling task thing works. And by the way, these what I'm in the database, it will store the user message like check email every 30 seconds. It will store all the tool calls it made to actually set this schedule, and it will store the final assistant message like, okay, done. Now after that, all the synthetic queries and all the tool calls and all the assistant responses to those queries, these will not be stored. These will not be stored. The reason is, for example, you set an alarm for like schedule the task for every 15 minutes. It means it will generate 4 of these synthetic queries. It will, let's say, run n number of tools, right? And it will generate 4 assistant response. So in one cycle, one cycle will put one synthetic queries and number of tool calls. Sorry for putting these force. So each cycle will put n tool calls, one synthetic queries, and one assistant response. Right. Now the problem with this is one turn basically means 2 plus n total. Let me just write it. One cycle means 2 plus n queries into the database, and it will scale. It will scale exponentially because every 15 minutes means 15 times, 4 times the total queries, so 8 plus 4n. So it will scale and it will pollute the context. It will increase your context size by a lot, and if you leave it running for like an entire day or entire week, then it's gonna just fill up your entire context. It's not really beneficial to put these synthetic queries and their tool calls and the assistant response in the database. So these are not stored, they are just passed to the client for context, and after that they are like removed. Basically we take a snapshot, we pass it to the agent, and then we remove the snapshot and only store the actual this message, like this cycle, not the synthetic ones. And then lastly, it also supports sub-agents, pretty cool stuff. Sub-agents do not have access to all the tools, and if I am correct, then it must be somewhere around here. Yeah. So the main orchestrator, the local agent, has access to all these tools. The sub-agent can only run bash tool, web search tool, and the URL fetch tool, because I do not want them to have their own sub-agents. Like orchestrator will spawn sub-agents, those sub-agents will spawn sub-agents. It's gonna mess up the entire thing. And also I do not want them to schedule tasks, because it just doesn't make any sense to let them schedule tasks. The Telegram thing has all the tools similar to what we have for orchestrator. The orchestrator doesn't have send documents over Telegram, nor the send images over Telegram, because it cannot really do that. So those are only for Telegram, right here you can see. So it has sub-agents, and the sub-agents will use the model that you have started the main agent with, so you cannot really use any of the model. I mean, you can make a pull request and change everywhere, it's totally open source, but for now it doesn't really support that. So yeah, the Telegram is a okay. Also, by the way, it does have SQLite, and it stores the entire OpenAI chat completion, params, union. The entire thing get marshaled and stored, and when we need it back, we basically query the database, take everything back, and marshal it back to the original type, and we just simply use it. It's pretty simple. These are all the core tools, as you can see here. These are sub-agents, these are Telegram tools. So you can read the README if you want to. Design notes: the process is resident. Final model responses do not stop the agent process. The file path and Telegram path both use the same LLM tool loop, but they have different input and output handling, obviously. File polling use a single default conversation channel, because if I had multiple agents doing it, then the entire chat history will break and maintaining context would be a challenge. Telegram uses one conversation channel per chat ID. Conversation history durable across restarts with SQLite. Responsive TXT can grow indefinitely, obviously. Oh, by the way, if you are talking over the TUI, then what really happens is, let me go to the, yeah. So I have two files here, message.txt and response.txt. I'm opening them. So let me show you something really cool. So if I close this here, and if I start it again, for that I will put some questions here, right? Let me ask ChatGPT, give me 10 random questions that you find interesting. So I will take these 10 questions, put these questions into the messages.txt file here, right? Okay, I do not need to remove this caps, it will get processed automatically. So I have saved these prompts in the message.txt file, as you can see here, right? I will start the agent. I am using the Gemini 3 Flash model. Do not ask me about the base URL, it's a completely different thing. Do not bother about it. I will start it, right? And as you can, this message.txt file is now empty. You might wonder why. Because TUI and the file polling thing work together. So while the TUI is working, the file polling is also working in the background. It will take all the questions from the message.txt file and it will sequentially process them. And it will update the TUI in real time. The first question was if you could know the complete and exact answer, right? If I could know the complete and exact answer to one question, I would choose what is the most efficient and robust way to perfectly align artificial intelligence goal with human values and well-being. So it is taking those messages from the text file, processing them sequentially and outputting the results in the responsive.txt file. If I go to the bottom, it is like 4,000 lines long. Crazy, I know. So yeah, user 1, let me zoom it a bit. It's too much. Yeah. If you could know the complete and exact answer to one question, what question would you choose? So it logs everything in a text file. So it basically can do like sequential stuff. You can just give it like 100 questions and leave it running. It will process everything. And if you want me to build something that batch processes them like like 50 agents working together, but those questions should be like not interlinked, they should not have any relation with each other, then I can obviously build an application that will spawn 50 agents. They will take 50 questions at once and process them at the same time. It's easy to make something like that. So if you want me to make something like that, please do comment down. I will get back to you, and it will keep doing it. And yeah, so and if I close it, I will not close it right now because it might lead to some corruption in the database. It will not, I am sure, but still I will let it process because I want to show you one more thing, right? So in the code base, if I go to the TUI, I didn't make any other TUI myself. I asked DeepSeek V4 Flash to make it, and the coolest thing is I was not really happy with the TUI because as you can see, this is not really cool because we are wasting so much of precious space with the padding and stuff. So I asked it to make its own TUI better, and this is what it made. Like, we can enter the questions here or the prompts here. This entire thing has been like made so much space efficient, and the color theme was also changed, and it shows the command, and also if it runs any tool, it shows the tools here like with a Thunderbolt icon or something like that. It shows this loader icon here, so it has made it very cool. Let me check whether processing has been complete or not. Question number 4, yeah, it's on 4 right now. There are 10 questions, so yeah, it will take some time. It really depends because this file is like really long, so you can guess how many tokens it's dealing with right now, so it will take some time, right? So moving on, so let's talk about, earlier I made it using Grok because it's really fast, right? But the problem was their context size. The context size is like really small on their models, like 128,000, maybe 256,000. I need something that have like at least a million tokens long context, and they're like not that many models. On Open Router, we do have one model like that, which is like really good for some reason, and it's a stealth model, Owl Alpha. So I use this, but it is pretty slow. You can see latency 3.22 seconds and throughput is 21 tokens per second. It's really slow, but the total context size is 1.05 million. So I use this, and also Nvidia put out a new model, Neutron Ultra, and it's also free for some time in Open Router, but 5.78 second latency and throughput 10 tokens per second. They were just too slow. So I started using Gemini 3, not 3.5, it's very expensive. I used 3 Flash PV. I'm using it directly via Gemini. So latency is 1 second, throughput 56. So like, yeah, it's good. If your priority, what? It doesn't make any sense, right? You get that on the default one, you get 1.16 seconds latency and throughput 69. On priority, you get 3.38 seconds and throughput 28. Like, what? Anyways, that's not our concern. So right now I'm using Gemini, but if you but the entire thing is made now using OpenAI. Where's the file? So you can just put in any base URL. Let me search for that. Base, not Grok. No, Open Router. It must be in this file only, yaar. I remember. I taken the model from current model. Yeah, it's current model. Alright, it's a global variable. Got it. And it is initialized from the user flags. Got it. Yeah. Earlier I had like I was basically hard coding it to use Open Router, but basically it now defaults to Open Router. It must have happened because of the I used Codex to actually find all the issues, so it must have made it, because hard coding is not a good solution. So yeah. Anyhow, so it's made using the OpenAI SDK. You can pass any base URL and the API key required, and it will just work. No problem. Yeah, here you are. Flag base URL. The default model is DeepSeek V4 Flash. It's a really good model, believe me. Then these are different flags. No flag TY and no TG. No TG will make it so that Telegram doesn't. It disables the Telegram bot basically. Flag no TY will disable the TUI mode and only enable the file polling thing. And it will force flag TY will force the TY mode. Will clear all the conversation history for both Telegram and local stuff. This will basically like the model flag which model you want to use. Let me check on the responses. Why is it stuck on 4th? I guess it's not updating. Let me here. Get responses. I guess it is complete, or maybe it's stuck for some reason. I'm not sure. I will just close it. Yeah, and launch it again. You can see the question. Maybe it got stuck, or maybe some due to the issues in here. It's not really working. Yeah. So this was the loader I was talking about. It's so cool. It's taking quite. Yeah, it's working. So yeah, this is something I have made in like 3 to 4 days, or maybe 3 to 4 days I would say. So I hope you find this project interesting. If you do, please drop the a like and maybe comment down the suggestions. And if you are a technical person, if you know how to code, please help me improve this program. We can open a pull request, you can have a talk, you can email me. I mean, I'm open to any kind of conversation when it comes to programming, so please feel free to do that. Till then, I'm Sumit and you hope you have a nice day. Bye bye.